I'll be sharing this session for ICETM 2025. This session brings innovative research, synthetic data creation, healthcare sustainability, and blockchain, all the breaking technologies together. We'll be hearing from a diverse group of people tackling the real world problems and like their innovative ways how they are solving these problems. Some of the ground rules for this session: each presenter will get 10 minutes overall. First 7 minutes is for their talk, followed by 3 minutes of Q&A. Please try to stick to your timelines so that we can accommodate all these speakers. We have a full session. I encourage the audience to take down questions and save them for the after the presentation is done, and we can use chat to drop your questions. So let's start and begin with our
Rajesh,
first.
good morning. And Jasneet ma'am, good morning. Nikhil here from MIT University.
Very good morning, sir.
So you started well before 11. Okay, just give me some
Okay.
time so that I can introduce my experts for this session as well as about the conference a bit. Just give me another 1 minute. We'll be going to start that. Then we'll be going
Sounds
for
good.
the presentation, sir. Just give me 1 or 2 minutes.
Sounds
Thank
good.
you, sir. Thank you.
Good morning, everybody. We are delighted to welcome you all to International Conference on Emerging Trends in Engineering, Technology and Management 2025, organized by Amity International Business School, Amity University, Noida. This conference brings together researchers, academicians, and industry experts to share their insights. IEEE is the world's largest technical professional organization dedicated to advancing technology for the benefit of humanity. IEEE and its members inspire a global community through its highly cited publications, conferences, technology standards, and professional and educational activities. IEEE is the trusted voice for engineering, computing, and technology information around the globe. IEEE has over 460,000 members in more than 190 countries, with more than 66% from outside the United States. More than 170,000 student members, 344 sections in 10 geographic regions worldwide, 2,700 chapters that unite local members with similar technical interests, 3,600 student branches at colleges and universities in over 100 countries, and 4,000 student branch chapters of IEEE technical societies. IEEE members are engineers, scientists, and allied professionals whose technical interests are rooted in electrical and computer sciences, engineering, and related disciplines. Amity University, in collaboration with IEEE, has come up with International Conference on Emerging Trends in Engineering, Technology, and Management 2025. The objective of the conference is to address the most essential issues of engineering, technology, computation, automation, and knowledge management. It also serves to foster communication among researchers and practitioners working in a wide variety of scientific areas with a common interest in improvement of engineering, technology, and knowledge. It aims to bring in the academicians and practitioners to jointly discuss and deliberate through their plenary talks and paper presentations on the theme engineering, information technology, operations, and knowledge management. The conference will provide a common platform to foster research relations between the universities and the industry. The vision of the conference is to bring together technology geniuses in one venue, not only to present breakthrough research in the area of computation and automation application, but also to promote practicality and applications in interdisciplinary exchange of ideas. Thank you. Now I would like to go on and session chairs for the track 2. Let me introduce Dr. Jasmeet Kaur first. She is currently working as Associate Professor at the Computer Science and Engineering Department, University Institute of Engineering, Chandigarh University. She has completed her PhD in CSE with the title Development of an Efficient Predictive Model for the Diagnosis of Chronic Obstructive Pulmonary Disease using Artificial Intelligence from Chandigarh University, and ME degree in CSE from Thapar Institute of Engineering and Technology, Patiala. With her teaching experience of 11 years, Dr. Kaur has worked as assistant professor in the Department of CSE, Chandigarh Group of Colleges as well. She has authored more than 20 research articles in reputed journals and conferences. Her research interests include artificial intelligence, machine learning, deep learning, computational biology, and software engineering. She is a reviewer with journals like SN Computer Science and various IEEE conferences. Let me go on and introduce the second session chair for today, Mr. Rajesh Kumar Pandey. He is a principal engineer at Amazon Web Services, where he leads the design of AWS Lambdas in eventing infrastructure. With deep expertise in distributed systems and serverless computing, he focuses on building resilient and scalable cloud-native architectures. Rajesh has authored technical papers, holds multiple patents, and actively shares his knowledge through industry publications, podcasts, and conference talks. Passionate about advancing the state of serverless event-driven systems across the industry. We are delighted to have you both.
Thank you so much, Janvi. Thank you.
Thank you so much, Janvi. Yeah, I think I started before you joined.
You started well on time. We are a bit late. Sorry for that.
No worries. Yeah.
Okay, now let's start with the presentations. Let me call upon the first presenter for today, Mr. Sambhav Gupta.
Hello and good morning to everyone. Am I audible?
Yes, you're audible.
Okay.
Please go.
So, greetings to everyone. I'll just share my screen, the presentation.
Some of it is important for you to turn on your camera also. and share the screen as well.
Okay. So is my screen visible?
Yes.
Okay. So once again, good morning, everyone. I'm Sambhav Gupta, presenting on behalf of my team. Team members Arushi Khanna and Bhageshwari Mukhopadhyay. We are excited to present our research titled WGAN-based synthetic data augmentation of biomedical voice measurement of Parkinson's disease. This research addresses data scarcity in rare diseases using generative adversarial networks to synthesize statistically reliable biomedical data. So, continuing with the introduction, our work tackles the critical challenge in Parkinson's disease diagnosis, the lack of sufficient high-quality labeled biomedical data. Using GANs, we generate synthetic data that mimics real biomedical voice features. This enables more accurate model training while preserving privacy. The results show that models trained on synthetic or combined data actually perform better than those trained on real data alone. This indicates that GANs could be an essential tool for predictive healthcare, particularly in data science environments. Let's start by understanding the problem. Rare diseases like Parkinson's often lack comprehensive data sets due to logistic and ethical challenges. This limits the development of AI-based diagnostic models. Furthermore, the privacy concerns around patient data prevent large-scale sharing. To solve this, we look around GANs, a type of deep learning framework, to generate synthetic yet realistic data that can fuel model training without breaching privacy. GANs have already shown promise in biomedical data generation, from ECG synthesis to electronic health records. However, there are concerns like model memorization and privacy leakage. Despite that, they remain a front-runner over methods like SMOTE and VAEs. In clinical settings, GANs can act as substitutes for real data, offering around for privacy and availability issues. Our study builds on those insights, specifically applying GANs to voice-based features for Parkinson's disease. So this is the GAN architecture that we have used in our study. We used a biomedical dataset from Kaggle that includes 195 samples, each with 22 voice features like jitter, shimmer, frequency, and nonlinear measures. Our GAN model is composed of two networks, a generator and a discriminator. The generator maps a 100-dimensional voice noise vector to a 22-dimensional output, mimicking real samples. The discriminator evaluates whether the input is real or synthetic. Both use fully connected layers, and the model is trained adversarially using WGAN-GP method for improved convergence. Talking about the training and strategy and ethical considerations, we trained the GAN for 5,000 epochs using the ADAM optimizer with a learning rate of 0.0002 and batch size of 32. Both networks were updated alternatively in a 1-to-1 ratio. Our loss graphs showed stabilized training, indicating good adversarial learning. These are some visual validation of synthetic data. These are histogram comparison of real versus synthetic data. So these histograms consist of two graphs. One, the legend, the blue legend is for real data, and the other color legend is for synthetic data. Both graphs should coincide each other for better results. So as we can see here, most of the data that has been generated synthetically coincides with the real data. Say these are the second step of visual validation for the synthetic data, the box plot comparison. We can see here that synthetic data really mimics the real data. So in these statistical comparison, we got a very good results. So coming to the correlation analysis, low Fourier norm of 1.63 shows our synthetic data preserves complex features relationships. Case test, the average p-value was 0.351, indicating strong statistical similarity between real and synthetic distributions. For the medical plausibility, all synthetic values fell within medical accepted ranges, confirming that the data was not only mathematically valid, but clinically plausible also. Coming to the model performance, now let's look at how this data performs in machine learning models. A random forest classifier trained on real data gave 94.87% accuracy, while the same model on synthetic data gave 92.31% accuracy, an impressive result. Similarly, the SVM classifier achieved consistent 84.62% accuracy across both datasets. High F1 scores and recall for Parkinson's cases affirm that the synthetic data can be reliable, used for diagnosis. So when we combined real and synthetic data, the classifier reached 96.1% accuracy, outperforming both individual datasets. This shows that synthetic data can augment and enhance existing real-world datasets. However, limitations remain. Our model is not yet suitable for raw audio inputs like any GAN-based method. It may suffer from occasional mode collapse. This is a study of biomedical voice measurements, not audio files. So, but overall, our GAN outperformed traditional methods like SMOT or VAEs by capturing non-linear dependencies. Coming to the conclusions and future directions. In conclusion, our study demonstrates that WGANs can ethically and effectively generate synthetic biomedical data. This data preserves both statistical and clinical realism, supports model training, and helps overcome data scarcity in Parkinson's diagnostics. In the future, we plan to extend this approach to raw audio synthesis and use conditional GANs for age or gender specific data generation. We hope this work paves the way for more accessible and privacy compliant clinical AI research. Thank you. We appreciate your time. And yeah, we are open for any questions.
Okay, can you just let me know that how GANs actually ensure the data generation?
Okay, so the GANs have two major models. One is generator and the second one is discriminator. So the work for discriminator is to identify which data is real and which data is synthetic.
Okay.
The discriminator,
So,
yes.
okay, fine. Now tell me if the data and the data is so overlapping, then what is the benefit of having this opposite side you mentioned?
I'm sorry, ma'am, but your voice just broke. Can you please pardon?
Okay, I'm asking you that if real data and what is the benefit that we will be getting out of synthetic data? What are the benefits of generating that?
Okay, so the main benefit for the synthetic data is, as I mentioned in my presentation, the data scarcity and the privacy concerns. Many of the medical data is not available to study or to make machine learning models with them because of the privacy. Like not every patient is open to share their clinical data. So the first, we solve the problem of privacy concerns. Secondly, the data scarcity, the data that we need to train our machine learning models is very huge that we need. But in reality, we do not have that size of that amount of data. So the second problem that we solve is this. And by overlapping the synthetic data on the real data, this validates that the synthetic data is really, really reliable. That can be used for medical purposes. Like if we generate synthetic data, but it does not coincide with the real data properties, not the data values, real data values. These are the real data properties, statistical properties that we coincide. So yeah, These are the benefits.
Okay, over to Rajesh.
Yeah,
Ma'am,
thanks. So please finish your thought, Samo. Yeah, I think it's a great observation. I was seeing some of the numbers that you showed, like the real data has like 94% of precision, and your synthetic data was close to like 92%. How big of that 2% gap is? Does it make model usable, or does it that 2% gap is actually big enough for us to not apply it into like practical applications?
okay, so this model randomly generates random noise, and then the discriminator confirms what properties are aligning with the real data. Every new instance creates a new data generation, synthetic data. So it is not like that this model always creates a particular particular quality of data. Sometimes it can generate a more accurate data, and sometimes it can generate a lesser accurate data. This is just a random generation. The main study that we have did is that any random generation should not come with a poor quality accuracy. So this does not set a bar that this model will generate a 95% accuracy of data. It can generate 93% also, and it can generate 97% also. It is just a random generation. So yeah.
Okay, got it. Okay, cool. Yeah, that was my main question. Okay, thank you.
Thank you. Thank you so much.
Thank you, Sambhav. Now I would like to call upon the second paper ID for today. The paper ID is 415.
Am I audible? And is my
Yes,
screen
ma'am.
visible?
Yes, please.
Yeah. Just a second. I'll just share my screen. Is my screen visible?
Yes, it's visible.
Yeah. Okay. A very good morning to everyone. I'm Akshay Vashni, a postgraduate student from EPCO's Clank Engineering College. I am really excited to present my paper, AI-powered inventory optimization with LGBM regressor at ICETM
Akshay, please
2025.
just
Yeah.
wait for a moment.
Yeah.
Jasneet ma'am and Rajesh sir, I have shared one link with you on WhatsApp. That is regarding the evaluation of the
Yes, sir.
presentations. So
Check, sir.
please keep on updating those marks based on the presentation of the student and the participant. Thank you. Please go ahead. Thank you.
Yeah, thank you, sir. Okay, it's all about machine learning to make smarter inventory decisions. Let me start with a very common situation. Imagine walking into a store looking for something and it's out of stock. You leave frustrated, and the next time, maybe you won't come back. This is a huge issue in retail. Businesses lose money in two ways. When they don't have enough stock, they lose sales, and when they have too much stock, money is stuck in the product that doesn't sell. Traditional inventory methods are often slow and do not respond well to things like festivals, seasonal changes, or sudden changes in the customer behavior. This makes business fall behind. So, what I wanted or we wanted to solve is we wanted something a smarter way, which is AI in our case. And the main idea of our project is to help businesses predict the demand using AI and manage their inventory better, as inventory is money sitting around in different forms. Here is what we set out to do. To use a machine learning model to forecast product demand based on the past data, and to automate restocking if the system is confident about the forecast, which means if the confidence level is above 90%, or else to alert a human manager, which is an inventory manager or someone who manages the inventory, if the prediction is uncertain, which is less than 90%. This helps the team make better decisions using real-time insights and trends. In short, the goal is to make inventory smart, fast, and accurate. To build this, we used a combination of tools like Angular 19 for the front end. This is where users see the dashboards and the reports. A Django for the backend. It handles the logic and connects everything. Every backend logic happens here. And the PostgreSQL to store the data like sales, inventory, and forecasting. All those data will be stored here. And of course, the hero, LGBM regressor from LightGBM, which is a machine learning model, which we have used to do the actual forecasting. This setup makes the system easy to use, make it powerful, and even ready for real-time decision making. As we see in the architecture diagram, this is how everything gets connected. The user interacts with the dashboard. Behind the scene, the backend runs the forecast. It compares it with the current stock and then places in the order automatically, and or else it sends an alerts to an inventory manager. Everything works together here to make the inventory management smooth and smart. Now let's talk about again the hero, which is the model. We used LGBM regressor, which is fast and accurate. It learns from the past sales data or other patterns to predict what is needed in the future. So if a manager selects a particular month, for example, let's say October 2025, the model can tell them how much stock they'll likely need for the particular month. And then based on that, the system helps in restocking decisions, like either it's restocks automatically or else it sends an alert to the manager based on the confidence level over there. When it comes to feature engineering, to make the model smarter, we have added extra features like the month, the day of the week, or the weekend indicators, all those stuffs, because the sales often depends on the time. And we have also added the holiday tags or seasonal flags, rolling averages, lag features, and then all of sales velocity. We have added all these things to detect the trend or the sudden changes in the customer behavior. All of this will help the model understand not just the numbers, but the patterns behind the numbers. Here is how the decisions are made. Forecasts are generated, like as we see in this diagram, the historical sales data, pre-processing, feature engineering, all those are done, and the model is trained. After the training, a sales forecast is generated. When the forecast is generated, it checks it with the current stock. All those steps happens on the backend, and if the model is very much confident, it automatically orders. If it is a yes, the confidence level is above 90%, it is direct yes, which then goes to a proceeding of ordering automatically. Or else if the model is not that much confident, which means if the confidence level is lesser than 90%, we alert the inventory manager and the decision is made by the manager. The manager can directly approve and the proceedings happen, or else the manager can modify the order list that the AI has generated and he can proceed with it, or he can abruptly reject the total order that can be placed. And this balance between the AI and the human is really important in the real world system, so that we don't have any chaos in the inventory management. We have tested the system with real sales data and got very promising results. In this, it is the rolling averages, like we saw in the before slides. This will be helpful to know the patterns of how the model would predict the future. This is the overall model performance, like we have generated it for the 10th month in 2023, as we have the actual data for that. We have a 93.15% of the overall accuracy, and the performance metrics like MAE, MSE, all those stuffs are being given over here. This is the top 10 predictions. Here we can directly see like the accuracy of 93, the actual data and the predicted data are very much similar. We have an accuracy of 93, 97, 99, and the overall accuracy would be 93.15%. Okay, the reason behind why we have chosen LGBM regressor is the accuracy, mainly the accuracy, because when we used ARIMA, SARIMA, SARIMAX, all those models, or XGBoost, even XGBoost could give you 91% of accuracy. But when we are dealing with numbers, like when it comes to inventory, we deal with numbers, and the accuracy is very much important so that we don't have any loss in our data, business. So we wanted a highest accuracy that was achieved only by LGBM regressor till now as per our analysis. Okay, it also helps us reduce the manual work, and it gave clear recommendations for when to restock and to avoid the restocking. To wrap up, the system uses AI to solve a real world problem in retail. It saves money, it improves customer satisfaction, and supports faster and better decisions. In future, we have planned to make it even smarter, maybe by using camera for shelf tracking or teaching the model to automatically adjust for different seasons. Thank you all so much for listening. I'm looking forward if there is any questions, and as a student, I'm looking forward for the feedback too. Thank you.
Okay. So you mentioned that you made a comparative analysis. Can we go back to that slide?
Yeah.
Okay. So here you have chosen only 3 to 4 more models you have made comparative analysis with, right?
Yes, ma'am. Even Sarima, Sarimax are in this, but like I didn't include it here.
You're just taken the competitive ones, right?
Yeah, yeah.
So I would like to give you one suggestion here that there are many
Okay.
more models that can be come up like as incompetent for your LGBM regressor model, right?
Okay.
So go and try those model as well. Some of them
Sure.
are support vector machines can be there. Histogram gradient boosting regression regressor can be there. Random forest you have used. Extra tree regressor can be there, right? So there are many more
Okay.
models that you can put in your comparative analysis that will even make your comparative analysis more stronger. So
Okay,
explore
sure,
more
ma'am.
of the things so that we can validate
Okay.
that why your hero is hero, right? Are you
Okay,
getting me?
sure. Yeah, yeah, yes,
So
ma'am.
MLP regressor हो गया neural networks में many more
Okay.
regressors are there.
Okay,
Right?
okay.
Non-tree, tree-based. So just
Okay.
explore all the things so that your research becomes more stronger.
Sure, sure, ma'am. Thank you. Thank you for the suggestion. Yeah, thank you.
Okay, Akshay, I'm just seeing your presentation. Is it a time series information?
Yes, sir.
So, have you checked the stationarity on those variables?
Sir, I'm not able to get your point.
Have you checked the stationarity on the variables which you have studied through these models?
No, no, not yet, sir. It's in an exploration phase, so not yet done all the steps. Yeah.
Reason being why I am asking it is when we have a time series information with us, the first and
Okay.
primary step is
Mm-mm.
that to check the stationarity. Stationarity means the constant variance as well as the constant mean.
Okay,
So
okay.
if your series is not stationary, then your results will be spurious.
Okay, okay, sir.
So do check the stationarity first and make it stationary. That you
Okay,
can do
sure,
with first differencing. This
sure.
is what the part of econometric models, which is what the ARIMA model is, which you have studied.
Mm-mm.
That is autoregressive and moving average model. Fine.
Yeah, yeah.
So do check it, because in moving average also, if you are not checking the stationarity, then the results might not be so much meaningful.
Okay, okay, sure, sir. I'll do
Right.
it.
Fine.
Thank you.
Rajesh sir, your point, you would like to ask anything?
Just like anything with like research, like I look for things around like what is the practical application. Like one of the things that you highlighted is like machine takes over into decision making. How do you
Yeah.
define that threshold when that machine should take over? Like what is
Yeah,
that
we are
point?
just thinking of 90% because 90% is also not good. But till now, as it is in the study beginning level, we thought of 90% would be good for the machine to take over the answers. If it is more than
Like
90%,
how do you define like 90% is good? Like how do you define like 90% is good?
yeah, using all these RMSE that we generated, the error values and all, we thought of doing with that.
No, I'm saying that like 90% is good or 95% is good. Like when does that threshold says that like what is the risk associated with like if you overstock something versus like do you feed that into your model to decide on whether you are
No, we
adjusting
think
the
above 90
thresholds
percentage
accordingly.
everything is good. Like we thought, like above 90% everything is good, but that is also not.
Okay.
Yeah.
Okay. No, it's something to like think through so that like you can improve these thresholds and set these thresholds so that like it's
Okay.
acceptable to be applied.
Sure,
Okay,
sure,
cool.
sir.
Great job.
Yeah.
Thank you.
Yeah. Thank you. Yeah.
Thank you. We'll now move on to the next presentation. I'd like to call upon Mr. Vineet.
Hi,
Paper
Janimi. Thank
ID
you.
666. Hello. Please,
Absolutely.
could you please switch on your camera?
Sure. Let me go ahead and share my screen as well. Can you guys see my screen?
Yes.
Perfect. Good morning to each one of you. And this is Vineet. Thanks to the entire conference team for making this happen. So today I'll be presenting about the work that we've developed with my co-author Samya on how sensitive data can transform the precision agriculture and how it addresses the critical data shortage problem in decision making. That's the overall agenda that we're moving towards. Let me move on to the next screen. So our presentation today will cover definitely 7 key areas. Number one would be I'll be outlining the data problem in agriculture and why it matters. Then I'll also share our conceptual framework that we've developed for sensitive data generation. And then we will also go through the AI techniques we propose to use. And then we will also discuss the practical applications across different agricultural domains. And we will share the challenges and limitations that are involved in this specific area of topic. And then we will also look at the future research directions. Moving on. So if you look at the precision agriculture systems, they would require vast amounts of diverse and high quality data. For example, we would also need the soil properties, we would need the weather conditions, we would also need the crop characteristics and management practices, because of which collecting all of this data is a significant challenge for us. And on top of that, if you look at the cost and labor intensity, that would directly make it much more comprehensive data collection expensive as well. So starting with the agricultural phenomena, which are completely seasonal, you can't collect all the harvest data in winter or maybe in a specific seasons, which are challenging, right? And on top of that, we also have high spatial variability, which means we need dense sampling networks. And for example, disease data sets are also heavily imbalanced towards healthy crops as well. And privacy concerns would directly prevent the data sharing between the farms. So all of these limitations would create a fundamental bottleneck for the precision agriculture advancement. And this is where the synthetic data offers a promising solution in this space. So the framework, the conceptual framework, this would provide a synthetic approach or systematic approach to generating the synthetic data in precision agriculture. So we will start with the limited real agricultural data, where we would apply all of the synthetic generation process, and we would end up with an enhanced decision support systems as well. So starting with the first part, which is the data characterization. This is where we understand where we're working with. And for example, when you analyze the soil moisture data, or we need to understand its temporal patterns, we have to look at the moisture information. All of that would change throughout the day. So that's the first key aspect that we have to look at. And second would be the generation method selection. So this is not definitely a one size fits all approach. For instance, if you're generating a specific crop image showing disease symptoms, or maybe any specific disease specific areas, conditional GANs would definitely work well for weather time series data, and conditional GANs would also work well for appropriate disease scenarios, for all the disease scenarios. And the third would be the validation, which would ensure the synthetic data follows the agricultural principles and physical laws. And the fourth part is where the application integration principles come into picture, which would incorporate all the synthetic data through pre-training, augmentation, or scenario testing. And this framework would completely be iterative and unique because of that system integration of the entire domain knowledge as well. Moving on to the specific methods, we have 3 key methods, which is the GANs, VAEs, and the diffusion models as well. So let's look at these, how they can generate the synthetic data. Number one would be, think of GANs as 2 networks competing. So where one would create a fake crop image, and the other one would try to catch the fake complete image. So through this competition, the generator would learn to create incredibly realistic agricultural images. And then this would include the conditional GANs, which are particularly powerful because we can specify what we want. For example, you can ask it to generate a corn plant at flowering stage with drought stress. And then cyclic GANs can transform between different types of imagery. For example, converting the RGB drone photos to simulate hyperspectral data. And you can also look at the progressive GANs, which can build high resolution images step by step, starting from small details to a specific perfect for creating detailed field imagery as well. And then VAEs would completely work differently. So they would compress the data directly into the mathematical space and then generate new samples from that space itself. This makes them excellent for time series data, which is like weather patterns or maybe sensory readings as well. And then the last part is the diffusion models, where this is the newest approach that everybody is leaning towards. They're incredibly powerful as well. So they work gradually by adding noise to images and then learning to reverse the process completely. Starting with the applications and use cases, so few major ones would be the crop monitoring. This would face challenges from cloud cover, obscuring satellite images and all of that. And our GANs can generate cloud-free composite images, which would restructure or reconstruct the complete crop information. The second part is the disease detection, where the models can suffer from extreme class imbalance. So we would generate the synthetic data images across all severity levels, for example, where we would create a balanced approach to training data sets for better models. The third aspect would be the yield prediction, which is completely reliable on the limited historical records as of now. But synthetic data can definitely simulate decades of weather data and then eventually simulate the management scenarios and all of that. And the last aspect is the resource optimization, which would definitely require the diverse scenarios to train on. But we would generate the thousands of synthetic management patterns, and then this would directly enable testing of optimizing the complete algorithms, the underlying algorithms. And we would also test those various conditions that are involved. So each application would demonstrate how synthetic data would fill all of these gaps, and because of which there were multiple challenges and limitations as well. For example, the model selection would be the key. Training stability is one of the major concerns that we had, and the domain-specific knowledge, which is agriculture, is a very less traction area. So because of which this is quite challenging eventually. So the future, the future approach would be a hybrid, where we're developing hybrid models that would combine the crop simulators with AI. And on top of that, neural networks would also ensure biological plausibility, and federated learning would directly enable all the agricultural farms to collaborate without sharing the raw data for each farm. That's where we were moving towards. And each farm can directly benefit from global patterns with having all of this data information completely private. And we can also build digital twins based on this, which would directly represent a major opportunity. And and also imagine which virtual farms are mirroring real operations exactly. And that's exactly which would eventually help all of these within the agriculture. So we talked about the comprehensive approach for the synthetic data in agriculture, and then this framework would also bridge the gap between the AI capabilities and agricultural needs. So the key innovation here would be the systematic integration of domain knowledge, which would eventually be executed. And then we've also shared a few AI techniques over here, and these applications would span from crop monitoring to resource utilization overall. So basically, the larger idea for our research is to contribute towards the precision agriculture effort, and this proposed framework would provide an initial roadmap on how we wanted to build all of these models eventually. That's the initial analysis that we've done, but we are progressing towards a specific methodology. Thank you. Happy to take any questions.
Okay. Can you please asking that? Can you just elaborate upon what kind of techniques your framework will be incorporating in order to handle the problems related with inconsistency in data?
Sure. So data sets are going to play a critical role going forward, because of which, sourcing all of the right information, sourcing the larger data sets, sourcing the disease information, sourcing the weather conditions. So procuring all of that data sets and then eventually generating the synthetic data would be the most critical one, or a P1 for us eventually. So for that, I think we need to collect the right amount of data from right amount of sources. So that would be the key for the model success.
Okay.
Yeah. Just like a slightly non-technical question is like, why did you choose this problem? Like, can you highlight that, the motivation?
I think the raw motivation would be coming in from a farmer family. I think we wanted to do something specific to the agriculture field, and because of which we started the preliminary analysis around the agriculture, where we can create a larger amount of impact going forward. So that was the primary drive for it. But I think going forward, let's see how it turns out.
What are you trying to achieve with the automation, right? Like what is your end goal with this? Is it scale? Is it accuracy? Is it Like
It's
what it is?
predictability. Predictability is number one priority for us. For example, it can be weather data or it can be the crop failures. All of those two aspects blended together would be the P1. As of now, I think collecting the data, I mean, given that we don't have any data, we don't have any kind of predictive models which can predict all of that information. So we wanted to add some value towards those two aspects. One would be the predictability aspect, which would give better insights to all the farmers, and then eventually bring in all of those insights and make sure the data is full documented.
Okay, and what else did you evaluate? Like I see, like you shown like some of the like deep DNNs
Yeah.
and like GANs you being used. Like, are there simple machine learning techniques that you tried and try
So
to get
GANs
like
are
good results?
not yet. So GANs are completely traditional approaches. So we're trying to integrate the AI aspect on top of that, because of which we're trying to source multiple models as well on top of these, and then integrate Gen AI eventually for that.
Okay, got it. Cool. Thanks.
Thank you.
Thank you, Vineet. Now let's go on to the next paper. I'd like to call upon Mr. Rajat Singh with paper ID 227.
Rajat, please share your screen.
Yes. Yeah. Wait a minute.
Rajat, are you ready to start? Okay, in the meantime, okay, please go. Yeah, sure.
Maybe there is some network issue.
Rajat, please hurry up. You just set your presentation. Let us start with the next participant. Okay.
Okay, sir.
Can I call upon Sandeep Kumar, paper ID 425.
Yes, ma'am. Hello.
Hello, can you start, Sandeep?
Am I audible, ma'am?
Yeah, you are audible.
Yes, ma'am.
Please start your presentation and share the screen, Sandeep. Yes,
sir.
we are able to see that.
Okay. First of all, good morning, everyone, sir. Good morning, everyone.
Yes, good morning. Please go ahead, Sandeep.
Okay. I'm Sandeep Kumar. I'm from Chandigarh University, and my project is a global forest cover change analysis, and my paper ID is 425. And it's project about forest analysis using NASA satellite images over 15 years. And forest play a crucial role in maintaining climate change balance. Sorry, sir. Sorry, sir. Forest play a crucial role
Just
in maintaining.
relax, and take time. If you want to grab some words, it's okay.
Okay, okay, sir. Okay. In this project, we analyze forest for 15 years using satellite image and image processing. In this, we use technique like image segmentation, and objective of this project is global deforestation and reforestation pattern are difficult to monitor. Then we mainly detect the forest where is deforestation and reforestation trend over 15 years from 1990 to 2005. They support environmental monitoring and carbon accounting and biodiversity conservation. Data source, we have taken data from NASA Global Forest Change and Earth Explorer, and Landsat images 7 Landsat THM plus 4 that include 7 and 8 Landsat images 7 and 8. This image consists red as deforestation, blue as water, and green as reforestation. In very light green that indicate deforestation, and dark green consists persistent forest, and every this image consists spectral resolution 30 meter. In methodology, we have load the GFCC image and we convert to HSV for the analysis and create a color mask. We have given the range of every color in a upper range and a lower range of just like green, green color range, dark green color, and light green color range, red color range, and we conclude the pixel after creating the mask. Where is the pixel is green, then create the mask and count that pixel. We have used Python, OpenCV, and NumPy. In color segmentation, HSV color, we have used a high saturation value. High saturation value. Visual comparison, we have used a visual comparison this is our result. We have used like this forest changes pixel count that so green color so 1992 to 2000 and red color so 2000 to 2005, and it consists of persistent forest and deforestation and reforestation. In this image we can see approx 20 million images in pixels in persistent, and in 1990 to 2000 and 2000 to 2005 it consists approx 25 million above, and also it so in the pixel like red pixel and red green pixel I have highlighted that indicate high rate of forest loss, provide visual and quantitative insights data. And in the future we I'm trying to integrate deep learning and CNN model to expand analysis across geographical location. Thank you.
Yeah, thanks for the presentation, Sandeep. This looks pretty interesting data set. How did you do the pre-processing?
Previously, sir, in this image we have deleted like I said I have used color segmentation. Then I take the pixel that I need only, and I remove the pixel like water, cloud, images, and using HSV color red counting pixel. I'm counting actually pixel. I'm giving the ranges of pixel like green pixel, red pixel. Every image consists RGB value. So I'm giving the RGB value in the range, but like every pixel had two level. एक तो upper dark or light. I'm giving the both light and green. Light
Okay.
and
how did you use the compute? Like, what was the resource that you used? Like, where did you get those resources to process this data?
Sir, sorry, sir.
Like, where did you do this offline processing? Was it done on cloud, or like how did you get the resources or boxes that you need to process this data? It's a
I have done
15
this
years
on
worth
the,
of image data.
yes, sir.
It's
I
a
have done
15
this on
worth 15 year. Yeah, sorry, go
yes,
ahead.
sir. Sir, it consists over 14,000 images, but I like in my processing, I can done only on some, I can done only on some images, but I'm trying to in the future, I can perform using deep learning or machine learning to perform all over the 14,779 images. I'm trying to, but I
Okay,
can,
fine.
okay, I can only run
Okay.
some images like 2 or 3.
Okay, thanks. Thanks.
Thank you. Thanks, sir.
Janvi, we can
Any question?
proceed with the next candidate. Thank you, Sandeep.
All right.
Thank
Very
you.
nice.
Thank you.
Before moving ahead, I'd like to call
Hello,
upon
ma'am.
Mr. Rajat again.
Yes, ma'am, I'm ready.
Okay. You can share your screen and turn on your camera and start presenting.
Someone else is here. Hello everyone, my name is I'm from the university and today I am here to present a research paper in a conference titled Cognitive Analysis of Underwater Data using Deep Learning for Marine Exploration with PID 227.
Rajat Beda,
Audio is
it's
particular.
done from your end. Fine. So you can mute yourself now and we can proceed further for the next participant. Fine. You can be the part of the
Yes, sir.
meeting. It is good for you, but your presentation is done now. We have evaluated it. Experts have done that part. So let's move to the next participant. Okay, Rajat. Okay,
sir.
you are left. Fine. So can you share the screen, Rajat?
Yes, sir.
Please share the screen fast. Are you facing problem in sharing the screen, Rajat?
Yes, sir. Actually, there is a network problem. My screen is not visible.
So how we will be able to see your screen there? I'm giving you time. You have 15-20 minutes. Please do that. Find out the place where you can have good internet connectivity so that you can present your presentation. Otherwise, it will not be considered as a presentation. Fine. So
Okay,
right
sir.
now we are moving to the next participant.
Sorry. Now I would like to call upon Mr. Prasenjit. The paper ID is 192.
Hello, can you see my screen?
Yes.
The screen is
Am I audible?
visible and you are audible, sir. Thank you.
Yeah, thank you very much for giving me an opportunity, giving us an opportunity to present our thesis. Just a minute, just give me a minute to. Our submission ID is 192 and our topic is predicting OTT subscription behavior using deep learning, a multi-class classification approach with feature engineering and class imbalance handling. My name is Prasenjit Chakrabarti. I'm the research scholar of Dr. K.N. Modi University and an assistant professor in management department in Technomain, Kolkata. And I have been assisted by Dr. Raj Sinha. She is from Parul University Computer Science Department. So how do I move? So now, so now I'm going to talk about the OTT industry, over the top industry. This is the streaming media. Now let us look into the recent IPL 2025 first three matches statistics. And Geo Hotstar came out with the data: 1.37 billion unique views and 21.86 billion minutes. Let's try to digest this now. 1.37 billion views means entire continent of Africa tuned in to see the IPL 2025 first 3 matches and 21.86 billion minutes. That means a human being constantly seeing the matches for 41,600 years. So a human person, if he starts from Stone Age till about 520 lifetimes, the person kind of numbers we are talking about in OTT. At present, this OTT industry is about 1.51 billion, growing at this CAGR of 13.5%, and expected to become an industry of 3.21 billion by about 2030. And this is, I'm quoting from Research and Markets. This is primarily fueled by the 1163 million wireless telephone subscribers and 902 million broadband services, making a teledensity of 82%. Here I am quoting the Telecom Regulatory Authority of India, March 2025 data. In fact, I have added the databases. What is our research objective? We wanted to look into this industry with our survey. We create a high accuracy deep learning model, fix data imbalance, identify top drivers and model performance, and then we call out the important information for the marketing management and marketing managers. In fact, we had looked into Netflix, Amazon Prime Video, Z5, Sony Live, and Disney Hotstar as our subject case, which account for about 82% of the market share. Understanding the subscription behavior, we looked for the questions were related to the reasons of subscription, switching behavior, or which in marketing term we call jockeying, or quitting, or the churn patterns, predictive model development, and obviously calling out the important key statistics. Now, in the literature review, we look for about 26 references, which we have added here, and 5 we have added in the index citations, which were related to bank customers, e-commerce platform, churn predictions, and subscription conversions using different machine learning models like XGBoost, random forest, then RNN, DNN, etc. Our survey methodology was that we collected a survey data, we did a data reprocessing, handling the machine values and encoding, and then we use SMOT for removing the data imbalance. Then we have split the data between 80% and 20% testing, and then build a deep learning model, MLP, and then we trained the model with 500 epochs, and using Adam Optimizer, we evaluate the model and finding out the accuracy, precision, recall, and influence score, and then we came out with the actual real life inferences from this data. This survey included data of the actual OTT subscribers using Zoho survey. It was an online convenience sampling, and only subscribers were used. In fact, there were questions, qualifiers questions, which eliminated non-subscribers, and our N was 506. Our Conrad's alpha was 0.91. So this platform, we asked questions related to Netflix, Prime Video, Hotstar, Sony Live, and Z5. Our questions were related. There were in total 23 questions, but then these questions were related to purchase motivation and personal preferences, pricing and promotional influence, brand reputation and perception, and perception, communication, advertising and exposure, and service experience and transaction needs. Now, based on this data, we segregated the responses into 5 clusters. First clusters was the cluster 0, what was loyal and engaged subscribers. And then we found the cluster 1 was the past subscribers. Basically, these were the churn people who have left, stopped subscribing. Then we had the cluster 2, which was the trial users or fence-sitters, which was the cluster 3 was an irregular, confused user. And obviously the cluster 4, which was a price sensitive clusters, basically the discount hunters or deal seekers. We use the models like we initially did the pre-processing, handling the missing values, then encoded categorical data and scaled the numerical data, and then you use the machine learning. We had 500 epochs, and data was fed into in mini batches of 64 with a learning rate of 0.0005, and we had learning reduces after 50 records, and obviously all other technical data we have added here. Now, we use initially there was a high class balance between these clusters, class 0, 1, 2, 3, 4, and we use more synthetic minority oversampling techniques to actually remove the class imbalance. This is the confusion matrix that we got. It is, as you can see, total number of reading was about 400, and the right reading was about 327. That is the diagonal values, giving a correct reading of 81.8%. Now, as you can see, if we look at this data, the perfect class is 0, where out of 208, all the actual 0, here the entire amount of the precision and recall was perfect. Then the class 4, which is the actual 4 and predicted 4, where there is about 69 correct prediction out of 89, which is about 78% correct in class 4. Class 2, 3, 1, 2, 3 had a mixed kind of a prediction value with a lot of missed predictions. Now moving to the correlation heat maps, we had 9 questions, top questions, which was found out with the model. One of the things that is coming out, that Pearson correlation is between 0.0 to 0.06, and hence that shows there is a very low multi-collinearity overall. But there is one notable things, as you can see in the top left corner, there is YouTube and internet, it is minus 0.24, this Pearson correlation. This indicates that if someone who consumes OTP via internet, they are less likely to rely on YouTube. So basically this is a good news for the subscribers, because if they are subscribed, they are not going to see the same past subscriptions or past episodes in the YouTube videos, which is freely available. And that is a good news. And this is the learning data. As you can see, this learning is continuously, gradually goes up. This is the blue color is the learning rate, and the green color is the validation rate. And the base epoch is achieved at 499, which is making the efficiency of 97%. Now, as you can see at 0.5 onwards, still on the top right hand side, this gradually goes up and they converges. That actually shows an overall good accuracy, no overfitting, consistent learning, and base epochs at 499, which I spoke earlier. Let's look at the performance metrics. As I have told earlier, the class 0 has got a F1 score of 1, and class 4 has got an F1 score of 0.78, having a recall of about 0.78 and a precision of 0.66. Class 1, 2, 3, which were the confused users, churned users, etc., they had a lower kind of course. And hence, we looked into class 1 and class 4 subsequently. These are the sharp data. As you can see, we have put the question numbers also. These questions, now if you look at the sharp data, question number 17, did attractiveness and popularity, it actually looks into the content satisfaction. Question number 22, did available payment options, it actually indicates the price sensitivity. Question number 21, did you purchase during the promo, it actually looks at the promo offers. And question number 10, how much did the price influence, is actually looking into the price sensitivity. And question number 23, was your purchase decision based on the scheme? It is again the promo offers. The 3 top culminators which is coming out very strongly is the price sensitivity, content, the content quality, and the content satisfaction, and the promo offers. Now, let's try to put all these numbers into perspective. The top drivers, as I have told, is the price sensitivity. This actually pricing policy, these questions were asked, pricing policy and you pay later options. These featured very prominently. It has got a moderate effect. And basically, as I have told you earlier, these are all class 4 matrices, which is actually the discount hunters. Similarly, there is also another thing is coming out is the promo offers, which is the purchase during the promo period and scheme influence. There we asked similar questions. As you can see, where we have got class 4 options and F1 score of 0.72. Also, the Schaff factors indicated that this is also a critical area. But the most important area which came out from the Schaff factors and as well as the class 0 matrices is the content satisfaction. Your needs and desires linked to OTT performances like Netflix and Hotstar, they came out as a very strong and unique content providers. Heatmap showed a mild positive correlation also, and this class 0 matrices shows a perfect F1 score of 1. And this is the class 0 matrices, and which is the main impact factor. So this model can help the marketers, media planners, churn teams in the marketing departments, and the campaign managers to tailor their campaigns. This can also help, the similar kind of models can also help the SaaS industries, tech, fitness apps, and digital news subscriptions. Main theme takeaway from this theme is the three, which we have thought about. Affordability drives decisions. Finally, Indian market is highly price sensitive and we take decisions based on price. Next is, but the quality over the quantity wins. Finally, it's the content satisfaction in OTT media. That's the key. And last but not the least is discount pull the users in, but it doesn't always keep them. So basically, we look for the promos, we buy the product, experiment, and most of the times we may discard it. These are the three key themes that I would like to leave out with for this OTT industry. Thank you very much. I will be very happy
First of
to
all,
answer any
sir,
questions.
yeah. First of all, I would like to really congratulate you. Your presentation was very well and detailed, researched presentation. I
Thank
was
you.
just getting the answer of all the questions that were coming in my mind at a point of time. So I just want to ask you one little question that can you just elaborate upon support as a performance metrics? Little more on that. You use
Performance
support
metric.
as a performance, yeah. Support you used as a performance metrics, right? Can you just elaborate that how it is going to help us understand our model better?
Basically, so if you look at our data, so you can get the performance metrics based on the sharp values, right? And the RMSE, as I have shown earlier, the model has got a consistent value of 81.8%, right? So that is also a good. It in fact, I have tried. We have tried different kind of models like XGBoost. We have used random forest. We have got a RMSE score ranging from 0.81 to 0.85 in different kinds of models. So does it answer your question?
All right, fine. Good to go. Rajesh, we can proceed with you.
Yeah, like I think I had a similar question as like ma'am has. Like I was checking, like you have like 5 or 6 OTT subscribers. Is that sample space big enough for you to like say that like it's a good representative of like overall?
No, I afraid not. Actually, this is actually one time. I think this is the research gap. We are, as a part of our PhD, my PhD is on B2B SaaS industry. As a part of this PhD, we are doing some another set of data. Basically, this is one set of data collection, which was done in around September 2024. Right now, we are doing another set of data collections to get the lateral view, to get a time series deviations in the behavior. So that survey is being done. Hopefully, that will bring in other perspective. So 2 points. 506 is definitely not the right amount of data. We can increase the data set, but at the same time, having data sets at different kind of intervals can give a better kind of a perspective about the consumer mindset, changing consumer mindset of Indian consumers.
That's good. Yeah, thanks. Nice, interesting presentation. Thank you.
So if there is no question, I remain here. Thank you very much for giving us the opportunity.
Thank you, sir. Now let me call upon Ms. Archita Singh, paper ID 418.
Hello everyone. From there, wait, let me share my screen.
Yeah.
Can you see my screen now?
Not yet.
Wait. Is it visible?
Yeah. Yes, it is visible. Please switch
Uh,
on.
yeah. So, hello everyone. I am Achita Singh, a BTech student from Amity University, Uttar Pradesh, and I'm honored to present my research on the topic bibliometric analysis on denoising diffusion probabilistic models, evolution,
Sorry to
application, and
Archita,
sorry.
sorry to interrupt you. Could you please
Yes.
switch on your camera as well?
Oh, wait, okay. I'm so sorry. Am I visible?
Yes, you're visible. Please go on.
So good. Hello again. Sorry. I am Achita Singh, from a BTech student from Amity University, Uttar Pradesh, and I'm honored to present my research topic, a bibliometric analysis on denoising diffusion probabilistic models, evolution, application, and future directions. Now, uh, wait. My God. Mm. Oh, yeah. Sorry. So first of all, the agenda. The agenda of this presentation is, first of all, we'll be talking about the DDPMs and the bibliometric analysis and DDPM research. Then we'll walk through the data collection and analysis tools, in which we'll be talking about the research methods and the data analysis which we have used. And then in conclusion, we will conclude the presentation with the results and future work. So now, first of all, the introduction. So what is denoising diffusion probabilistic models? It is a class of generative models that create data through step-by-step denoising process. And in DDPM, we use two kind of passes, which is forward pass and backward pass. In forward pass, the structured data is progressively corrupted with the noise, and in backward pass, the model learns to reconstruct the realistic outputs. Uh, so yeah, so these DDPMs are much more stable than GANs, which and these are used in the models like Glide, latent diffusion, etc. Now, bibliometric analysis and DDPM research. What is bibliometric analysis? Bibliometric analysis is a quantitative method to study scientific literature by examining publications, patterns, citations, collaborations, etc. So we have used two processes in bibliometric analysis here, which is co-citation analysis and co-occurrence analysis. These both are used in bibliometric analysis. First of all, co-citation analysis. Co-citation analysis examines the instances where two documents are cited together in the same source, and co-occurrence analysis identifies two or more terms appear together in a research. So data collection and analysis tools. For data source, we have used a tool called Dimension.ai, which was developed by Digital Sciences. It provides access to wide range of scholarly content, publication like articles, journals, citations, grants. And we have the field which we have used was title and abstract. The query which we put it in this dimension was denoising diffusion probabilistic model and image generation. So our data covered five research domains. Research domains which were like computer vision, information and computer systems, machine learning, etc. Now for data analysis, we have used two powerful tools, Boss Viewer and Bibliometrics in Art Studio. Boss Viewer is basically used for visualization terms, and Bibliometrics is used to extract the annual publication trends. So in this study, we have used 346 key documents related to a DDPM, and we have extracted that to WAS viewer to visualize all those things. And the circles and labels represent nodes, and the greater circle represents the greater significance. So now it's time for the result. So firstly, publications in DDPM. Here you can see in the graph that from DDPM was getting popular from 2020 to 2025. Like it's a peak time of DDPM. in 2020 we got very few research papers on DDPM, which were like introductory research papers and all. Between 2022 and 2023, we can see that we had 129 research papers published on DDPM, and in between 2024 and 25, it's like a peak expansion period. We had more than 160 plus research papers published on DDPM. So the second is most co-cited, second research is most co-cited sources. So cited source co-citation analysis is a technique used to identify most influential literature in the DDPM. So in 980 cited sources, we have 980 cited sources, only 80 pass the threshold because we chose the frequency greater than 10. Now, most co-cited sources. Here you can see I have made a table, which tells us about which says highly TLS source in DDPM research. What is TLS? It is total link strength. It is a matrix of assessing sources' overall citation impact on the network. So the listed source highlighted in the table is the most frequently cited sources, books, and paper prints in DDPM. So yeah, here you can see I have got the graph with the use of Watts Viewer. Uh, here you can see that most cited source is ARXIV. Here you can see the biggest circle is of ARXIV with total citations of 311 and the total link strength of more than 13,000. And among these top 10 most cited sources, 6 are cited by IEEE and the rest are cited by other conferences. So here you can see that node represents the individual source, while the lines between them denotes the co-citation relationship between the nodes. And here you can see that we have a lot of yellow circles, and we have a lot of green circles and red circles. And the same colored nodes represents that they belong to the same cluster. Now, most co-cited references. Co-citation analysis of cited reference concentrates on specific words like highlighting most impactful document in DDPM. We have out of 3,520 cited references, only 95 were chosen because we wanted to isolate the significant research achieved in DDPM based on the citation levels. So here you can see that we have divided it into 4 clusters, and all the 4 clusters tells about different things. The red cluster, the cluster number 1, tells about the highlights the achievements in highlights the advancement and achievements in DDPM. And the second cluster, which is green in color, cluster 2, emphasizes the application and extension of diffusion models. And the third cluster, which is blue in color, focuses on improving and optimizing diffusion models. And the fourth cluster focuses on comprehensive exploration and categorization of diffusion models. So now co-occurrences of keywords. We have also made a graph on the keywords based on keywords. So yeah, as I told earlier that we got 346 DDPM related documents on VOSView, on Dimension, and we got 4,891 terms extracted. But we used only 111 terms because we wanted only those terms who had occurrences more than 9 times. So we have divided it into 5 different clusters. Here you can see that, yeah, we have 5 different clusters of 5 different colors. The first cluster, which is red in color, here you can see all the clusters which is red in, all the nodes which are red in color. This shows that they belong to the same cluster. The first cluster's theme is denoising diffusion probabilistic models. Here we have n equals to 19 and denotes the number of keywords. Here we have 19 keywords, which are like DDPMs, generative models, denoising diffusion probabilistic models. All these are keywords which we have extracted. And the second here you can see the green colored cluster, which is DDPM and deep learning techniques.
Archita,
Yes.
Archita, can you come to the part where you can just conclude your entire findings that
Yes, ma'am. It was
bibliographic
about to come.
analysis कर लिया
Yeah.
हाँ कर लिया लेकिन इसका अब फायदा क्या है what is next, just let me know that.
So first of all, मैंने सबसे पहले ये बताया कि DDPM का एप्लीकेशन क्या है, एंड इसके बाद यही है कि the contribution क्या किया है कि identifies research hotspot and influential publication shaping DDPM field or establishes conceptual framework which will help further researchers. And challenges which are यही है मैम computational
Where are
efficiency
you going
is
to
a
use this
major challenge.
bibliometric analysis now? Itna research kiya, right? Now what next? What are you going to do with it?
Bibliometric analysis, ma'am, first of all, when we decided to this topic that we wanted to make text to image, so bibliometric analysis paper helped us a lot. We got a paper on bibliometric analysis which helped us a lot, which gave us the list of all the research papers which were related to these. So it
And
will
just tell me
help
one thing.
researchers.
I
Yeah.
hope you agree with this that the platform is very important from where you're extracting your documents.
Yes, ma'am.
You really feel the platform that you chose is the enough and the only one, and it is
No, ma'am.
the
No, ma'am.
only
Absolutely
platform
not.
that you should have
No,
used
no.
for that.
No,
That is a
absolutely not, ma'am. We
limitation
have
for your
used
approach.
this platform only because it was free. We did not want to pay money. We use this
Why
platform
you did
because
not
it
go
only
for the
because
other platforms like Scopus? There are
yeah,
many apps which
Scopus,
are
ma'am.
freely available. You could have got
Yeah,
for Scopus,
we could have
DevOps side.
used.
Why you did not
Yes,
go
yes.
for that? Why did you
Ma'am,
go for that
because
AI platform which gave you the easy things? Huh?
no, just because it was free. Yeah, because Scopus, they charged a lot of money,
Did
and
you
as a
ask your
student and
university
for
for that?
year.
Did you ask for your university library mein jao, बैठ के पढ़ोगे? You will get access
Yeah,
to many
actually, we could
platforms.
have do that. But at that time, our placements were also going on, so we didn't go there. We got all the things, so yeah.
So always go for an authentic source. Over to you, Rajesh.
Yeah, I had a very similar question. Like, what was going on in my mind is like, okay, I have done all this research. Can I, like, if I say that, like, I want to launch my startup and I want to host this model and serve this data to customers and slap a front end in front of it, can I build a subscription business from it? And it's like, I think ma'am asked that same question is like, what should I do with this analysis now? So I think that part I didn't clearly see like coming out clearly from here. Is there something for the end customers here?
So
because Archita, when
sir,
you always go for a reliable research, so they go for a reliable data basis from where you're extracting the data and collecting the data. That is the first prime question you will be facing everywhere you go when you are presenting your research. कहाँ से लिया? चाहे वो data set है, चाहे वो papers है, from where you have referred, right? So just take care of that for the future.
Yes,
thank you.
Absolutely. Thank you so much, ma'am.
Thank you, Archita. Now I would like to call upon the next presenter for today, Ms. Sana Parveen, with paper ID 209.
Good afternoon, ma'am.
Good afternoon.
Yeah, let me share my screen. Is it visible, ma'am?
Yeah, it is visible. You can start.
Okay. So, good afternoon, everyone. This is Sana. I am MTech Data Science student from MIT University, Noida. So, the title of my research paper is Predictive Model of Sleep Efficiency Using Machine Learning and Analysis of Lifestyle Factors, Sleep Patterns, and Chronological Features. So the main objective of this paper is to predict the sleep efficiency by leveraging advanced machine learning techniques on a rich database comprising lifestyle factors, sleep patterns, and demographic variables to overcome limitation of traditional statistic models that fail to capture non-linear relationship and feature interaction in sleep-related data. To evaluate and compare multiple machine learning regressor, linear regression, decision tree, random forest, gradient boosting, support vector machines for the effectiveness and sleep efficiency predictions, to identify key influencing features, for example, sleep duration, REM sleep percentage, caffeine and alcohol intake using explainable AI methods like shape values and permutation importance, to pave the way for personalized sleep enhancement strategies by offering predictive insight tailored to individual living conditions and habits. Moving ahead, so introduction to sleep efficiency and its challenges. We first of all we will understand what is sleep efficiency. So sleep efficiency measures the proportion of time spent asleep while in bed. So low sleep efficiency, often caused by frequent awakenings, leads to poor sleep quality and health risks like mental illness and heart disease. Complex influences, there are a lot of other factors other than at what time you're going to bed, at what time you're waking up. There are other factors also which depends and which varies from person to person. For example, these factors are like caffeine intake, sleeping time, age, gender, interact in complex ways affecting sleep quality. Traditional studies often miss these interactions, limiting personalized insights. Moving ahead, so I have taken data for the data set. I have taken a data set which is available on Kaggle. So it consists of 452 entries with 15 variables. So these variables include age, sleeping phases, I mean light sleep, deep sleep, and REM, and caffeine and alcohol consumption, gender, smoking status, and sleep wake up time converted into numerical values. So for the data challenges, there were some missing values in the data. So I have missing values were imputed using median and mode. Categorical values were encoded. For example, male and female were categorized to 1, 0, and smoking status, smoker, non-smoker to 1, 0, 1, and alcohols in the same way. And the daytime features, for example, there was a wake up time and sleep time. So I have calculated the duration to implement it into better way. So daytime features engineered for analysis. So for future enhancement, we can include environmental factors like room temperature, noise, screen time, variable devices that could improve model accuracy. Moving ahead, so this is the complete plan, the methodology which I have implemented. So first one is data preprocessing, imputation of missing values, encoding categorical value variables, and conversion of time features to numerical form. Model training. So 5 regression models are being used: linear regression, decision tree, random forest, gradient boosting, and support vector regressors. Hyperparameter tuning, grid search, and randomized search CV optimize parameters to improve model performance and reduce overfitting. And explainability, sharp values and permutation importance used to interact feature contributions and interactions. So, about the findings of my model. So linear regression, the values, there are different values which you can see on the screen. So for linear regression, you can see it is 0.0039 to R square value 0.7917, and decision tree it is 0.0061 and R square value 0.6740, random forest 0.0027, 0.8554, and gradient boosting 0.00282 to 0.8512, support vector it is 0.00542, 0.7018. Among all 5 models, random forest has performed the best, and the second one is gradient boosting regressor, and the worst performer in this model is decision tree regressor. So discussion and insights from the model performance. So the top performance, random forest and gradient boosting excel due to their ability to capture non-linear relationships and feature interactions, where R square was around 0.85 and low mean square error. So the limitation, this highlights the limitation in simpler models. Linear regression showed model performance, while decision tree support vector, they also struggle with generalization and kernel stability respectively. So the key factors which are highlighted, which affect the sleep efficiency, are sleep duration. Sleep duration is still stand out to be the most important factor of sleep efficiency. So and the REM and deep sleep. REM is basically your random eye movement, which tells how much your brain is active, right? It helps you to develop it also helps in the emotional building, your memory building. So REM is very important, and the sleep these REM and deep sleep are the crucial psychological phases impacting sleep efficiency consistent with prior research. And lifestyle habits, caffeine and alcohol consumption affect sleep but vary by individual factors like age and gender. So lifestyle, we cannot generalize it like saying a person is having higher caffeine or higher alcohol consumption will have a less sleep efficiency. It depends on other factors as well, like with age and gender. Like with age, you can some people show sleep efficiency less. With high caffeine, some might not show. So it depends on the lifestyle plus their other factors included. So conclusions and future direction. So effective prediction, machine learning models, spatially assembly models accurately estimate sleep quality from lifestyle and demographic data. Personalized recommendations, finding enable tailored sleep improvement strategies beyond generic advice. And future research incorporating environment and wearable data can enhance the model accuracy and sleep real-time personalized intervention. So we can make a more we can to improve it, we can also make it, we can go beyond that by including other factors like what was the screen time of the person who was going to sleep, what was the noise in the room if he or she was sleeping, and exercise also plays an
All
important
right,
role.
Sana. Sana, can you just tell me that how did you choose your performance metrics?
Performance, yeah, I have calculated mean square error and R square for
How
the
did you choose that these are the two perfect metrics to evaluate your research or model?
Generally, mean square gives the best result. It tells not just how far the values are from each other.
Not generally, Sana. Just tell me in context with your application problem.
I mean, I evaluated other one also, but again, this shows the best result. So it was, uh, I mean, not anything. I tried and then I found that mean square and R square shows the best results.
I would say that you must explore other performance evaluation matrices as well in order to validate your model, that why I'm
Yes.
saying this is perfect one, right? You must have some other matrices also. And if I'm asking you this question, you must have an answer for this key. This is the reason in context with my application, this is the most suitable performance evaluation metrics, right?
Yes, ma'am. Depending on the papers, ma'am, I have read. So I made an analysis like going for the.
उसने किया था, इसलिए I'm doing that. Not that. You must know it. Getting me?
Yes, ma'am.
Okay, thank you.
Okay, thank you so much.
If there are no more questions, I'd like to call upon the next presenter. Okay, Mr. Rajat, are you ready now? Yeah, I can see you now. Can you share your screen?
We are not able to hear you, Rajat. Please start. Please remove your earphone. We are not able to hear you or reconnect it. It will be better if you can use your laptop's microphone.
Now audible?
Yes. Please move ahead.
Yes, sir. My name is Rajat Singhal. I am from Sharda University, BTech Computer Science student. Today I am here to present my paper on the topic cognitive analysis of underwater object detection using deep learning for marine exploration. Paper ID 227. So here's the questions comes with what is underwater object detection? Underwater object detection is a computer vision task that focused on recognizing and pinpointing the positions of the specific objects in underwater environments. It helps in identify the marine species, debris, or infrastructure damage in the oceans. So how we come this? As we all know, our Earth is covered with around 70% of water, and it has been studied by WHO that over 80% of the ocean remain unexplored, which limits in the understanding of marine life, resources, and ecosystem. There is a strong need to explore and monitor marine diversity, underwater devices, and human presence in the water. Underwater environment face significant challenges due to the poor visibility, light absorptions, and suspended particles. So here we are provide with we are come up with an YOLO V11 architecture, a state of art object detection model for its speed and accuracy. We have curated a composite data set which consists of different type of data sets like aquarium data set, brackish underwater data set, human presence data set, underwater plastic data set, which consists of different type of classes. Here is a unified class graphs that marine lives are present. 10 types of objects are present in data set, 4 human object classes, and 12 underwater services like plastics, mask, bottles, tires. So by applying the augmentation techniques, flipping, rotation, cropping, hue, saturation, to operate to simulate it in the real water environment and remove all the challenges of poor visibility and all. By training the YOLO V11 architecture on a dataset using RoboFlow pipeline, which provide a proper end-to-end solution from dataset composition to training. Evaluation model performance using precision recall and mean average precision metrics. So here is our algorithm, which will define how we use the interference pipeline by using the RoboFlow. So now come up with the training setup. We have set up our training with a YOLO V11 architecture and fine-tuned it on our custom dataset. We have used the RoboFlow platform, which help in data acquisition management and also annotate and augment the data. For training setup, we have used the GPU-enabled system with and pass our dataset with an input size of 600 and 600 pixels images. So now come up with an result and comparisons. As you see that our model will perform a high accuracy in predicting correct objects with 90.5% precision, 85.5% recall, and mean average precision of at 0.5, 90.4, and with the mean average precision at 0.5 with consistent IOU threshold. We have also compared with other models like faster RCNN. Faster RCNN is a model which pass the image in the two stage. So we have chosen that which pass the image in a single stage and better for real-time object detection. As you see that YOLO V11 is a bounding box, detect the object in a bounding box. As in the results, you have here it determine the tires in the images and the phase arcs and type of phases in the model. So now come up with the discussion. YOLO V11 outformed older model like faster RCNN, YOLO V4, YOLO V9 in both precision. YOLO V11 is developed by Ultralytics company, which is the advanced implementation of their old YOLO versions, YOLO only ones. Robust performance on a real world under environment due to the data augmentation techniques. Slight trade-off in recalled 85.5% suggests some objects may still be missed, and we have done this in the future. So this study successfully developed a deep learning model for accurate classification and detection of marine life such as fishes, penguins, jellyfish, starfish, and other objects like human presence, devices. The model achieved high accuracy. In future, we are addressing the more challenges in poor visibility and also apply our model in the vehicles like ROVs, UAVs, and the camera stations for detecting the underwater objects and explore the environment. Here is a current list of review references we have used.
Thanks, Rajat.
Hello. Hello, sir.
Hey, can you hear us?
Yes, sir.
Yeah. Just like what is that specific characteristics that makes it like YOLO V11 works better than like your faster RCNN? You know, like what characteristics actually helps
Yes, sir.
that achieve better higher precision?
YOLO V11 is actually a single state process in which the image is passed in a single stage, and it process the image and make the bounding box around the object, which helps in the the image. And faster RCNN is a two-stage process which pass the image in two steps. Like first it process the image in segmentation, then after that it process the little bit of the image. Then it leads to some gap and not even determined in real time and the faster. So YOLO V11 comes into the picture.
Okay, makes sense. Okay, cool. Ma'am, do you have any question?
We can proceed. Next candidate, please.
Sure. So I would now like to call upon Ms.
Thank you.
Rashi Bhatu, paper ID 436. Rashi, are you ready?
Good afternoon, ma'am. Yes, ma'am. I am just ready with screen. Is it visible, ma'am?
Yeah, it is visible. Could you also turn on your camera?
Yes, ma'am. Just a second. It's visible, ma'am?
Yeah. Please start.
Hello.
Please move ahead, Rashiji. You are visible and audible also.
Thank you, sir. Thank you so much. A very good afternoon to respected dignitaries and all the members over here. I am pleased to present my work titled Blockchain-Driven Solutions for Transparent and Secure Communications in Eco-Friendly Networks. And this research basically explores how blockchain technologies can simultaneously ensure secure communication and promote sustainable ICT practices. Let's begin with the introduction. Begin with the introduction. As communication networks grow increasingly complex and resource intensive, traditional centralized systems fall short in terms of both transparency and security. So blockchain with its decentralized tempered proof architecture offers a promising alternative. And moreover, in this context of climate change and what we call it, carbon reduction targets, blockchain with the energy efficient framework is very essential. And this study is going to investigate how blockchain can address these dual challenges, which is ensuring secure communication while promoting eco-friendly digital practices. If I talk about objectives of my study is to develop transparent and secure communication framework using blockchain and to examine energy efficient consequencing mechanism to propose validation algorithms for transaction verification and integrity, and to evaluate integration of blockchain with emerging technologies like IoT, 5G, edge computing. Methodology I have opted here is like in the study we have opted for both theoretical and simultaneous based, which is relying on a centralized authority. Our model uses distributed consequences to verify transactions, and we focus on three key metrics: the fairness of validation process, the detection of data tampering, and the comparative energy consumption of different blockchain algorithms. This structure basically approach helps us to ensure data integrity, transparency, and environmental sustainability. Moving ahead with blockchain capabilities in network. So this blockchain basically secures communication through many validation processes, and instead of a single point of a failure, multiple nodes verify each transactions, making it more reliable for the cyber attacks. And this decentralization builds trust among the stakeholders and enhances the transparency, which is an essential requirement to secure the data environments. If I talk about how transactions are validated here, so the validation process begins when the users intimates the transactions, and this transaction is basically a broadcast to all the nodes, which then verify maturity. Once a maturity consequences is achieved, once this is achieved, based on the predefined threshold, the transaction is validated and recorded permanently on the blockchain, ensuring trust through hashing. So here we have talked about that how blockchain uses hashing to create a unique identifier for the each block. If even a minor change is made, the hash value changes drastically and thereby exposing any tampering. This hashing mechanism ensures data immutability, which is vital to secure communication system. If I talk about saving energy through better methods, so here we have used traditional blockchain saving energy with better methods. So here we have talked about traditional consequence mechanisms like proof of work consume vast amounts of energy, and we explore alternative consequences models, namely proof of stake and the proof of authority that offers comparable security while drastically reducing energy consumptions. And these models make blockchain not just because more of that environmentally viable. If we talk about role of blockchain in IoT, 5G age, and smart contracts, so blockchain utility extends beyond traditional networks. In IoT, it ensures secure identities for billions of devices. In 5G networks, it enhances data integrity and reduces latency. With edge computing, blockchain secures localized data processing, smart contracts, automate operations, and such as access control with the management, which ensures shift to the rule-based decision making. The challenges faced with the research are like, despite of the advantages, blockchain faces many challenges like, first, the older models still consume excessive energy. Second, which I have gone through is scalability issues emerge as more users join to the network. Third, a lack of unified regulations, compliances, global interpretations. Lastly, the technology still faces regulations factors in many jurisdictions. In conclusion, we'll be talking about like blockchain stands out the transformative solutions for secure and eco-conscious communication networks. It decentralizes data validation, enhances transparency, and resists unauthorized alternations. The transactions of energy efficient models like POS and POA further aligns blockchain with the sustainable development goals. The addition of smart contracts enables autonomous network management, significantly improving reliability and operational efficiency. As we move towards a more connected and a sustainable future, blockchain emerges as an enabler to this vision. Thank you.
Okay, Rashi, can you just elaborate upon that? You mentioned eco-friendly networks, right?
Yes, ma'am.
Just elaborate more upon that. What will be your points to justify that eco-friendly networks? Give me some keywords.
Ma'am, eco-friendly networks, right? You're asking about eco-friendly networks. Hello?
Yes, Rashi.
So, ma'am, eco-friendly networks are the networks basically, if I talk about eco-friendly networks, ma'am, that networks which are not harming the environment.
Okay, can you just give me some keywords that how our technology that we are talking about is going to do so?
Keywords for eco-friendly are like which. Hello?
Yes.
Hello? Ma'am, like those who are environmentally friendly, reducing carbon footprints, etc.
Okay.
Like you have your conclusion slide. If you open that slide, you talk about it, right? Like I think ma'am is asking those two keywords. If you can read them out, like you talked about like the specific things which reduces the energy consumption is like you use different hashing and like technology, like methods, like algorithms, right? Proof of stake and proof of authority. That actually makes it more eco-friendly. Where
Okay, sir.
instead of consuming
Rajesh,
like
you have
gigawatts.
been their savior. You have been their savior.
Yes, ma'am.
Yeah, it's just like trying, like I think it happens, but like what I wanted to ask is like, can you explain like what is
Exactly. We are
proof of
talking
stake?
about Rashi, we are talking about blockchain, right? And then we are talking about eco-friendly network, right? So you have to
Yes,
just relate it. How our technology is assisting in achieving that, what we are saying. All right, Rajesh, do you have any question?
I think this was a prerequisite to my question actually. So maybe we can end it here. Okay. Thank you. Thanks, Rashi.
Thank you, sir.
Nikhil sir, are you there?
Thank you, sir.
Hello.
Sir, as informed, I have a meeting now. I have to leave. Rajesh will be proceeding up, I hope, with the session now.
Pure man, thank you, Jasneet ma'am. Thank you for the time. I can
All right, thank
understand.
you, sir.
I have worked with the Chandigarh University for 2 years, so we can understand the pressure in Chandigarh
Actually,
University
just
for
looking
sure.
at the schedule shared in the mail, I just scheduled it for one. So I have to take a leave. Thank you.
Sure.
It
Thank
was
you.
pleasure being with you people. Thank you. Okay,
Thank
Rajesh.
you, ma'am. Thank you.
Yeah, thanks, man.
Okay. Moving on to the next presentation, I'd like to call upon
Mr. Harshit Agarwal with paper ID 226.
Hi, can you all see me?
Yeah.
Hi, good morning. I would like to present my presentation just a minute. Can you all see the presentation?
Yes, we can see. Please go on.
Hi, good morning. This is Harshit Agarwal. I'm under the guidance of Dr. Subhash Chand Gupta, and along with my partner, Vipul Mansal, we have presented a model on customer churn prediction for a subscription service. As we all know, customer churn is a big has a big effect on the users, the revenue, and the business stability. It is a big concern for many businesses since it affects them a lot. It includes some voluntary, involuntary, and passive churn types. There are 3 types. Churn basically means how many customers are actually available for a specific business, how many are actually using that subscription type or a subscription model or a business on a regular basis. Higher churn can mean increased customer acquisition because as churn increases, the number of customers also leave because of many reasons. There can be many reasons. For example, we have actually discussed many reasons in this PPT, and I'll have to show you in the next slide. It can our model can identify risk using behavior, transaction, and demographic areas. Addressing churn actually fosters loyalty of a customer towards a business. It improves and strengthens the customer relation with the business. Now, we have used a telco customer churn prediction datasets, which includes up to 3,300 values and 21 categories. It was available on Kaggle. It includes customer demographics. It includes the service plans like annual, quarterly business plans, half-yearly, monthly, call charges. That's basically the amount of charge a customer gets on their call. It could be monthly, annually, semi-annually, or even international calls. The churn history, if the customer has actually left the business before and he has joined the business afterwards. We have used pre-processing techniques to address the missing values, to address the data type conversions, and to remove the duplicate values. We have used several models, but 6 of the several models like KNN, SVM, random forest logistic regressions, XGBoost, decision trees, and several other models. But 4 of those models were closely related, so we have discussed upon that in this PPT. There was include logistic regression, decision tree, random forest, and XGBoost. For a methodology, we have sourced the dataset from telco. For data cleaning, we have ensured that no missing values are there. We have removed the duplicates. And we have also removed irrelevant features like maybe gender for our model integrity. For data transformation, we have converted categorical values from numerical formats. We have extracted our variables which mostly affect our churn values like voicemails, call charges, international plans, business plans, charges, etc. We have trained the model from the get-go to get the cleanest data set possible for our churn patterns. We have evaluated accuracy scores, F1 scores, precision, recall. We have made ROC curves. We have made classification matrices for all this for a good comparison. We have prioritized our transparency to understand why a user might leave a business, on what factors might a user might leave the business. These models can be integrated into a business system for real-time churn prediction. We can use these models for real-time churn if if we want. Here's a model accuracy comparison graph. Our highest performing model was random forest. Second came XGBoost, third came decision trees, and at last it was logistic regression. We have also attached a recall score, a precision score, reference score, and support table. As you can see, as you can see, our accuracy table is of decision trees, where our reference score came out to about 0.89 for the accuracy, as you can see. Next, for the feature importances, this is a feature importance table bar graph. For our highest performing model, which was random forest, the total day minutes of a customer, it was one of the most important features that affected the churn value of a customer. Second came the interaction plans. Third came the customer service calls, the amount of support calls that a customer made to a business regarding their issues. International plan customer service emerge as a significant factor, as I have said, and customer service interactions play a critical role in churn. Mid-level predictors, including total interaction minutes, while assuming factors like night calls and international calls, show minimal effect. Total day calls and account length offer little to no predictive value. It means that a customer, if he was on a monthly plan or an annual plan or a semi-annual plan, means it offers little to no churn prediction in our model. These findings suggest that targeting payment behavior addresses customer sports will be the most effective strategy for churn mitigation. Like total day minutes is the most effective feature for our churn mitigation process. We have implemented, why is our model advanced? Because we have feature explainability for each of the type of categories we have used. We have multi-model benchmarking, like we have evaluated different models for our prototype, and out of those 7-8 models, we have chosen random forest and XGBoost as well. Both are very similar, but XGBoost needs a lot of computational power to execute a program. We have used advanced data type cleaning steps. We have focused on a real world data set and practical focus. We have seen retention strategies. We have offered target CRMs. So that's how our model is more advanced. Conclusion, our model gives us a high accuracy score. It identifies key drivers. It offers us insights. It offers a robust methodology by using multi-model comparisons, and it can be improved later on by other people, but I have done my best to make a model from with my partner. Limitation, yes, let's talk about the limitation that I have. The scope of the data set is very limited. The size of the data is very limited. We have the data set is roughly 3,300 values, which is a rather small data set, I would say. A good data set should be roughly around 8, 9, minimum 10,000 values. We have not supported real-time churn as of now. And we have also not integrated data integration streaming this program. It relies heavily on available features that are currently available right now. We have not estimated customer sentiment or customer behavior. Like these days, social media could be a big effect on a business. If let's say a post from a social media from a business is very bad towards a customer, then it could affect the customer churn on a specific business. And class impact, that is fewer churns. It could affect the recall and false negatives because of inherent class imbalance, fewer churners related to non-churners. So that's it. These are some of the references that I have used. And thank you. I will answer to any questions that you have as of now.
Thanks, Arjit. You talked about like you removing some of the features from the data set that you got. Like, what was the reasoning behind that? Like, why did you choose certain features?
Yeah, let's say we have a customer data set that has like roughly 30-40 categories, right? I don't suppose that gender, for example, when I was training a model, gender was one of the categories that did not affect our model. Like a person, be it a male or a female, it did not affect whether they were churning out of a business or not. Similarly, some categories were had very small or minimal effect, little to none effect on the churn value of a business. So we have just gradually removed it. For example, if I kept those models, if I kept those categories in my model, they were giving me an accuracy score that was just a minimal better or maybe even worse in some categories. So I've just removed those categories from my model to get a simple and clean data set and a rather simple model.
How did you evaluate whether it's not overfitted? Like you have not, your accuracy is around 95%.
Yeah.
I think you hit that. So
Yeah.
how were you making sure that like it's
okay? When I trained the model, when we trained the model, we use smooth and epochs as well on our model. While running epochs, while data cleaning, after data cleaning, when we were pre-processing the data, in the pre-processing, there were many random variables that were duplicates. For example, like I said, the male and female that were giving me little to no effect on our accuracy scores. So we just thought it was making our model more heavy. It was making it more computationally
it was a
extensive.
manual evaluation and
Yeah. It was a whole
okay.
lot of manual labor.
Okay.
So we just thought let it be automated and let us just make it automated only. Let's remove the manual labor part. It was a lot of work for us as well to remove each for a specific data set to be evaluated for small accuracy scores. So we just automated the scores.
Okay, cool. Makes sense. Thanks, Arshad.
Thank you. So any more questions, anyone? Or should I?
I think ma'am
Since there are no questions, I will move on to the next presenter.
Okay,
I'd like
thank
to
you.
call upon Dr. Himanshu Bagh.
Yeah, I'm just stopping my. So sorry.
Dr. Himanshu, are you there? Dr. Himanshu, paper ID 437.
Hello, sir. So he's just joining within a minute. There is some technical glitch.
Okay, let's move to the other one.
Can I call upon Mr. Arshdeep Singh Bhatia, paper ID 318?
Yeah, good afternoon. Am I visible?
Yeah. You can start.
Is my screen visible?
Yes.
Okay. So, good afternoon to all. I'll be presenting my paper on the topic developing Flask-based image generator application using OpenAI's DALL-E and Replit, and this will be a comparative analysis. So, introduction on the topic. This topic is mainly based on generative AI. It is a subfield of artificial intelligence, and nowadays the image generation applications, as we see in WhatsApp, in Instagram, we have seen Meta AI, and it also uses the same kind of technology to generate images based on the prompts given by the user. It also uses natural language processing and computer vision and various other different technologies. So the objective of this project, it addresses the topic of generative AI, as I said earlier. It involves, it mainly involves integrating Dolly with AI-driven web application, which we have developed. And it also gives us a comparative analysis between the images generated by DALI 2, DALI 3, and EMU, Meta AI's EMU, and also some neural style transfer and using a CNN model. So the methodology we have used in our research, the front end was developed using HTML, CSS, and JavaScript. And after the user logs into the application, the user can give the prompt to generate any image and for any size, for any resolution, and how many number of images the user needs to generate. and it will it will mainly be focused on the user's inputs. So the backend is built using Flask. It handles the API calls and the user request. When the user types in the prompt, the Flask calls the API and processes the request based on the user's input. So the generated images can be downloaded using the link provided. And in this, Flask was leveraged on just for the integration of OpenAI's DALI and uh, from the user and for the user inputs. The backend will call the OpenAI with required parameters based on the user's input. The Replit IDE is Integration Development Environment, which was leveraged for the development environment variables and dependencies, and management and hosting also. We had created a new workspace which contains all the architecture required for making the environment for the application. So this is a flowchart for how the application will go. The user will log in with his account. If he does not have an account, he will create an account and go to the main page and give the input. The input is then processed using Flask. If there are internet connectivity failures, the application will inform the user and proceed back to the user input prompt screen. And then the input will be processed and an image will be generated, which can be then downloaded. So now we come to the comparison part of the project. So in this, we will be comparing 4 models: DALI 2, DALI 3, Stable Diffusion, and Meta AI's EMU. These will be compared on 2 same inputs, which will be the same prompt: create a headshot of a professional software engineer dressed in business formals, and the resolution will be 1024 by 1024. We'll compare them on 3 main metrics: sharpness, entropy, and inception score. These are the image generated by 4 models: DALI 2, DALI 3, EMU, and Stable Diffusion. Now, neural style transfer. Neural style transfer we have used to combine contents of one image with the style of another image. Content image refers to the image which has preserved the structure and layout, and style image refers to the image in which the text, color, and the patterns are preserved. So this is the result of a neural style transfer, where we have taken content image as DALI 2 image and style image as DALI 3 image, in which the style and layout is of the DALI 2 image and the patterns are of the DALI 3 image. Now the results and analysis. So on the basis of sharpness, we have calculated sharpness using the Laplacian variance algorithm. And sharpness basically means the edges that are present in the image and what is the image quality. So greater the Laplacian variance, greater the image quality. So as we can see, the DALI 2 Laplacian variance was 231.54. DALI 3 was 1794.7. Neural style transfer was 317.92. Stable diffusion was 256.48 and EMU was 63.63. So according to this, DALI 3 has the highest sharpness score, and others have a comparatively very much less score. And as I discussed earlier, the neural style transfer, which has both DALI 3 and DALI 2 qualities, but it also has a lesser score. So now on the basis of entropy, entropy means the randomness in pixel distribution, how the pixels are distributed across the image, and pixels are basically known as the building blocks of an image. So as we can see, the DALI 2 image has an entropy of 4.98. DALI 3 has an entropy of 5.10. Neural style transfer has 4.71. Stable diffusion has 4.51, and EMU has 5.08. So according to this, there are not much differences on entropy, but DALI 3 again has the highest entropy, and majorly entropy score of 4 to 5 means a moderate image, and higher than that means a good quality image. Now on the basis of inception score basically means how realistic an image looks, and we used Kullback linear divergence to get the inception score. And as we can see, the inception score of DALI 3 again is the highest, and we have the lowest score of lowest inception score of neural style transfer. As we can see here, DALI 3 has the highest, and DALI 2 is followed by DALI 3, but all the other three have very less inception score. So we can imply from this research that DALI 3 has performed best in all the three metrics, and the neural style transfer, although it has DALI 3's properties, but it cannot be compared to the actual image derived from DALI 3. These are the references. Thank you.
Thank you, Ashdeep. I think like how would I differentiate between the result that you got versus me querying these models on my own? Like, what was different there?
So actually, could you repeat? I couldn't perfectly understand the question.
So if I go to DALI 3, like all these, like maybe OpenAI, and I go and play with the image models there, and
Yes,
your
sir.
result, I could also conclude that same by just querying once. That like like DALI 3 is better than
Yes, sir.
DALI
Yes, sir.
2. So like how did you like say that, like what was the novelty in like your research?
So we actually compared on the basis of all the three scores, as I said, and we used different methods like the Laplacian variance method, the Kullback divergence method, and we also developed our own application so that people can do generate images of DALI 3, DALI 2, Stable Diffusion, EMO on the same application, so that they can compare themselves, not by going on different websites and all, just doing it on the same application.
Yeah, so I get the class application, but like how many times did you like try this? Like, and did it stand out? Like how many repetitions you run?
So
Like
we
what
did
was the test?
around 50 or I 50 to 60 epochs we did. We ran the code,
Okay.
and we had some difficulties doing this project, but in the end it turned out to be good.
Okay, okay, got it. And like, what was the latency numbers? Do you remember? Like how did they compare to each other? Like,
Sir, I
what
can't
is the
recall
practical
that.
application? Like, what is the practical application if I have to go towards that, and like
Yes, sir.
one good model, but it takes a lot of time to like generate these images, then it's of no practical use, right?
So practical application right now, and we can see in the field of art, there are many NFTs also, and many other different projects also for different architectural projects, for different projects of a company. They need a 3D view of an image, or 2D view, so they can develop generate these images based on the inputs they give to the application.
Okay, okay, uh, okay, sounds good. Thanks.
Okay, thank you, sir.
I have no further questions.
Any other questions?
Thank you, Arshdeep. I would like to
Thank
call
you.
upon Dr. Himanshu now.
Hello.
So, yeah,
Hello. Is audible?
yes.
Good afternoon, everybody. Myself, Dr. Himanshu Bishanbak, Assistant Professor from MIMT, Greater Noida. So, please. Hello. Just 1 minute, ma'am. Hello. Hello.
Yeah,
Just 1 minute.
yes. Sure.
Excuse me, ma'am. Hello. Hello.
Yes.
Am I audible? My PPT is visible?
Yeah. Yeah, you're audible. Your PPT is also visible. Can you switch on your camera also?
Just a minute. कैमरा कैसे ऑन करना मैडम कैमरा कैसे ऑन करना कैमरा कैसे ऑन करना है कैमरा कैसे ऑन करना है स्क्रीन शॉट हो रहा मैं से नहीं लिख रहा Shall I start my presentation? Hello. Hello.
Sir, can you please turn on your camera before starting? It's right next to your mic, bottom left corner. Dr. Himanshu, you can start. It's okay.
Hello.
Yeah, you
Hello.
can start.
Sorry for the inconvenience. Actually, there is a technical error. My topic that is your developing scalable energy storage and systematic to ensure the continuous renewable energy for power data. As you know that in the current scenario, that is the huge consumption of power here, and in increasing the worldwide demand for the clear energy technology in changing now campaign the including the data centers look for at energy efficiency and sustainable data centers, which are key component for the digital economy, require reliable available power supply to support their growth workload and acceptable by the fact that occupy the significant portion of the global electricity consumption accounting for almost 1% of the overall load. So now can visible that what the requirement of the power.
So your
Hello.
voice is breaking and it's really hard to hear you.
Am I audible properly?
Your voice is breaking in between. Do you mind changing your location or shifting by a couple of chairs here and there?
Sorry for that. As you know that in the current sorry. The increasing world demand for the clean energy technology is changing in how companies, including the data center, look at energy efficiency and sustainability. Data centers, which are key components of the digital economy, require the reliable and available power supply to support that growth and the workload. Hello.
So please continue. I think we are seeing some issue. If you could just rush through your slides, that would be great. We cannot hear you. Nikhil sir, I think there is some issue that technical issues that we're facing. So
Yes. Shall we give one more minute if things can be resolved at his end? Or
sure. I'm fine with that.
Imanshu, are you there? Imanshu. Imanshu. Imanshu, are you there? We are not able to see you nor hear you.
I think we lost him. Janvi, I think we can end the session. I'm not sure whether we'll be able to reach him answer.
All right, sir. So before concluding the session, we would really love to hear something from you. Could you please share your insights about the session, about topics, about the research?
Yeah, I think this was really wonderful and really refreshing for me to attend like academic sessions. And it's been like I think around 12 years for me to since last I joined college. So this was really refreshing and seeing a lot of things that we do in industry and I hope you guys have heard of like Amazon Web Services and like I work with
Yeah, of
serverless
course.
technologies. A lot of things that you guys do, you make use of it. It's a wonderful technology, and it's really available and scales to like a lot of needs, a lot of projects that like I think I remember like one guy was looking to process satellite image data. I think it's a real technique that you guys should use and use it to further refine your understandings, refine your results. But yeah, this was really exciting session, and I loved all the presentations. And I know like this was the last one. I am pretty sure this was also exciting one. We couldn't hear from him.
Likewise, sir. Thank you so much for your wonderful questions and insights.
Thank you, Rajesh sir. Thank you for your valuable time. You are with us throughout the session from, in fact, well on time or before on time. We are late, but sorry for that because we are waiting for some something from our end. But thank you, sir. Thanks a lot. We'll meet you again.
Yeah, thank you. Thanks everyone. Yeah, really nice session. Thank you.
Thank you, sir. So now we are ending this session. Thank you, participants, for being the part of this prestigious conference.
Sir, will we be provided with a photograph of during our presentation, or the video link will be shared?
So you can send that query on the conference email ID. You will be able to get the answers from there. Okay, sir.
Sure. Okay. Thank you.
Okay.
Thank you.
Thank you. Thank you.
Take care. Okay.
Thank you. Okay, sir. Bye bye.
Thank you, sir.
Thank you.
Pranay sir. Pranay sir. Pranay sir. Hello. Pranay sir.